All right, taking apart these Tesla taillights is pretty easy. First, to get it out of the car, you will have to remove some of the interior plastic trim. That's pretty straightforward. And then besides that, there's 4 bolts that hold it on. And the plastic trim is hiding 2 of those, and the other 2 are visible even without the trim removed. And then this just pops off. Just kidding. This is broken. You might have to pry it off with a screwdriver, but just be gentle. And then in here you have 4 5.5 millimeter, for whatever reason, screws. There's 1, there's 2, there's 3 hiding up there, and then number 4 is right there. So I'll take those off. All right, so those 4 screws are removed, and this will lift off. I already unplugged the plugs, but there are 2 plugs, one here and one here. You just pinch and they pull straight off. And now we've revealed the fun star drive screws. There's 1, 2, 3, 4. So we'll take those off real quick. All right, so those 4 screws are done. And if we lift this up and flip it over, we can see all of our LEDs. I've already sort of played with this a little bit to no avail the first try, but now I have the right LEDs and we'll solder those on. I'm sure you're looking at this and saying there's no chance that that works, right? Yeah, this is awful. This was my first attempt. This was my second attempt. Because the contacts were really bad, I had to solder these connecting wires just to make sure I got good contact. This is my third attempt up here. Still pretty ugly, but the contacts weren't as corroded up here since the water pools down here and not up here. So these were bad, but at least the contacts were still good, so they were easy to solder. Okay, so, you don't believe me. Watch this. My incredibly sophisticated testing rig, and I'll press the lock button. Yeah, all of them work. So I'll show you in a second how to take apart the taillight, but basically what happens in the taillight is water gets into the lens, settles at the bottom where these LEDs are, and corrodes those LEDs. So the actual diagnosis is that the lens lets water in, and then the symptom of that is that the LEDs and the electronics inside end up going bad. Getting a new taillight for the old Model S is something like $300 to $400 for a decent one, and I fixed this for less than $5. With all of the prototyping I had to do and figuring out, it was maybe $20 to try out all the different LEDs and get things right. And then I also had to buy the sort of sealant to go around the lens so that this doesn't happen anymore. But if you're comfortable with a soldering iron and maybe a benchtop power supply, then you can do this yourself. If not, maybe leave a comment below or something like that, or maybe I'll have some contact information in the description. And especially if you're in Southern California, I can fix it for you. And if you're in the US, maybe we can figure out some shipping things. But it's if you have soldering experience, it's not that bad to do yourself. If not, I wouldn't recommend trying this. Now, now I'm talking to people with soldering experience or people who want to learn how to solder. This is sort of the harder version of soldering. So, sort of conventional soldering is just soldering 2 wires together or something like that. This is SMD, so surface mount soldering. And you can see these contacts are much smaller. But basically I got these diodes. Maybe I'll leave the part number in the description below, but you have to get the right diodes, and I couldn't find them on Amazon. I had to get them on Aliexpress. And the way that these diodes work is there is sort of a slotted side, and that's where the positive end of the diode is, and then a not slotted side. And there's 4 legs on these diodes, and I had to trim off one in order to get it to work. I have no idea why. If you do know why, please leave a comment below letting me know. And then this is the diode notation, and that diode notation is actually on the board. So there's the diode notation, and let's see, you might be able to see the little cutout in the corner of the diode. And the diode notation is flipped throughout the board. So this one goes up, this one goes down, that one goes up. So you really have to pay attention to those. And as long as you snip that one leg, it should work. You can use your benchtop power supply set at 2 volts and 100 milliamps to sort of test as you go. And you can also take this whole board and just plug it in, you know, to the dangling taillight of the Tesla and make sure that it works. If you have any shorts, or if you solder any of the LEDs wrong, then it can make either all of the LEDs not work, or it can make just sort of one of the arrays of the LEDs not work. So be aware of that. If it's working and then all of a sudden none of them are working, just, you know, unsolder the one that you had just done and everything should work again. You know, you can't really burn out these LEDs unless you put way too much current and voltage through them. If you run them backwards, they just won't work, which is really convenient. It's also important to note, you know, plug your board in and figure out which LEDs are already good. You don't want to replace the ones that are good. And you also need to know which banks are together. So I know these 4 LEDs run together, and I'm pretty sure those run with these 5 and these 4 and this one here as well, but I'm not certain on that. I know for sure that these 4 are on a separate bank than these up here, and you can actually see, if it's in the right angle, the sort of etching between the LEDs in the board. So there's no etching between this LED and that LED, but if there is, yeah, you can see it better in this light now. You see the zigzag? So those LEDs are connected, and those up here are on a different bank. So you don't want to use the, you know, the wire connection between 2 different banks of LEDs, or your turn signals will look weird. So this board was sort of, I would say, like a medium corrosion. So this is definitely salvageable. If you have a bunch of green corrosion, it may not be fixable at all. It may have corroded the, you know, the internal traces inside of the circuit board. But admittedly, you know, this one did look pretty bad, at least to my eyes, to begin with. And so I had to snip the old LEDs off with this. And then I used some fine sandpaper to sort of file it down. And, you know, if they aren't very corroded, your contacts should still be okay just by snipping them off. You can add a little solder to the contact pad and then put the LED on if you want. If you're using the wire to connect them, hopefully you can see that. You see how 2 of the legs on this LED are sort of bent out? So I folded them out and then put them over the wire, and then there's 1 leg on that top left one. And that's what worked best for me here. If you need to, you know, salvage the contact pads, if some of your contact pads are damaged, just run that wire all the way across. If your contact pads are fine, you don't need to bend the wire out. You still need to trim that 1 leg. Note that this is upside down now, or upside down from that previous one. But I didn't bend the legs out on this one. I just put a little bit of solder on the existing pad and then trimmed it flush, and then put the LED on very carefully and just touch the solder to heat it up to sort of reflow it onto the LED, and that worked fine. I would highly recommend, you know, trying an LED, testing it, make sure it works, and then move on to the next one. If you do a big batch of them, there's a good chance you'll mess up, either solder something upside down, or you might solder that 1 leg that's supposed to be cut by accident, or something along those lines. All right, so this is how my board looks right now. You can see I've already sanded some things down and taken off some components. So the whole thing wasn't working just now, I think because I had actually just soldered a wire directly across these pins here. And if there's any short or anything in the circuitry, then none of the lights will work. You know, what we need to do is get these diodes soldered onto here. We can use just some normal wire. This is braided copper wire here. You know, I'll strip back the insulation a bunch and then get strands of the copper wire. We can use this is 240 grit sandpaper. You want to use a pretty fine grit if you need to sand down the contacts, but I'd recommend especially if the condition of the board isn't too bad, just snipping them. It's also nice to have this pair of needle nose pliers to actually hold the diodes in place. I've got nice real lead solder over here. This is, if you want this brand, this one is really nice. It's kind of expensive, but you get a lot of it. I've got my soldering iron off screen, and I've got a power supply set to 2 volts, 100 milliamps to test the actual components of the board. Okay, so the pointy side is the negative side of the little diode symbol. And if I connect the wires, you can see that it lights up. Or connect the leads, rather. And it only lights up this bank of LEDs, right? It's not lighting up any of the other LEDs. So this whole bank is on one thing, and that bank is working. So then we can move down to this bank and make sure all of these work. Oh, that's still on the same bank. Let's try these. So those 4 still work. So these 4 work. All of these work up here. Let's see if we can get a good contact on these. I don't think any of these LEDs are working. I can't get a good connection on any of them. So I'm going to take all of these LEDs off, and I'm going to prepare my LEDs, my new LEDs, to solder on. So like I mentioned, you can just snip them. That one was pretty broken. You can see the corrosion is really bad on this board, but I think it's still going to be pretty salvageable. These just shoot everywhere. So I can feel with my finger that there's some raised pieces that need to be trimmed, so I'll trim those. And I don't know of any chemicals. I'll also do this one here. That went into another dimension. I don't know any chemicals that are going to clean up that corrosion nicely. So I really think this sandpaper is the best bet. If you end up exposing the traces underneath the circuit board like I did, I don't think that's a big deal. If you get water in your taillight again, then it will be a big deal. But if you seal the taillight properly, that shouldn't be an issue. So we need at least some of the metal exposed. You can see that that metal is exposed there. And I know from doing that other taillight that these are going to be on 2 separate banks. I don't know where the banks are demarcated, but we're going to have to figure that out. So this is just some 70% ethanol. You could use isopropyl alcohol too. This is just what I have around. Most of these contacts are pretty nicely exposed. So I'm going to try the first method of just adding just a spot of solder on and not folding the pins. So these are magnifying glass. That is the LED. This is the LED. So it has 4 legs. And 1 sort of cut off side. Just flip it over. So those are the 4 legs. You can actually fold these legs out if you need to. And you can see there's 1 cut corner there. This side with the cut is going to be the positive side, I believe. And then the one without the cut is going to be the negative side. We're going to need to trim the leg in this view of the diode in the top left. All right, I'll show you the first method that I have. If your contacts look really good, you can go in with a clean soldering iron. These contacts are really pretty. So I'm just going to add a little bit of solder. Just a little bit. To each of the contacts. And then I'm going to prepare the LED by snipping off the 1 bad leg. So to do that, I just fold up the leg very gently and snip off as much of the metal as I can. So we want to make sure we don't get solder on that 4th leg that we had to snip off. So then it's sitting on the metal, and there should be enough solder just by touching it, we should be able to get the solder to flow onto the leads. So I'm going to hold it. And get it exactly where I want it. And then the other leg. Just going to hold it there for a second and the solder will flow, I promise. So the inspection that we need to make is not necessarily that it's perfectly straight, because it's not going to be, but that the fourth pin that we trimmed isn't making contact. And actually when you connect the power supply to it, if that fourth leg is connected, you'll hear, I sound crazy, but you'll hear the electricity. If it's a quiet room, you'll hear the electricity flow through, and that means you did it bad. I wish you could hear this, but I can hear it. So it doesn't hook up this way, it hooks up this way. And there's like an electronic noise. So then what that means is that I accidentally got the solder to flow on that fourth leg. So I'm going to try to trim it. You can also try to reflow the solder. Just wick up a little extra of the solder. There we go. Fix that one. So that one is working now. And so I'm just going to repeat that whole process for all of the other contacts. All of these have the arrow pointing up. These have the arrow pointing down, with the exception of this corner one, for whatever reason. And I noticed as I went along, only one of the diodes was working as I went. So, but now when I test them, so as I did each diode, I would test one at a time and they weren't working. I started over here, so I did this one, that one worked, I did this one worked, but this was the only one that lit up. I don't know why. Let's see if we can test these. There we go. So you see all those light up except for these three at the end, but if we test these individually, they all work fine, right? So what I'm thinking is that the traces between all of these is messed up. So what I'm going to do is, I'll show you, I'll take some of this stranded copper wire, strip the insulation off, and I'll twist these together and I'll solder them across all of those, and hopefully that fixes the problem. If this video is about to save you $300 to $700, please like, comment, subscribe. It really helps the channel grow. Even if you don't want to watch any more of my videos, subscribe to the channel. It really helps a lot. So anyway, adding that strip really helped. I extended it to the next working LED in this strip just in case, and I was very careful to only solder to that one pin on the LED rather than both of the pins, because this side is the positive side. So I was very careful to do that, but that whole strip works. So now I'm just going to do these last 5 and hopefully be done. All right, before I forget, I also have this solder fume extractor out of frame, and it comes with these helping hands, which are super helpful. Okay, so this one LED right here had the same issue as these 3 on the ends. So I just added this bridge again, and you can see, oops, upside down. That works. All those LEDs work. See? All right, so the reassembly process is pretty easy. Here's the taillight without the lens, and here's the LED array that's been repaired. So we just put that on, and the first set of screws are these annoying star bits, and you just put all those in. Okay, so this is the assembly without the lens and without the backing. The star screws are put in. Now we need this component. First we need to plug in these wires, and then this sits just on top like that. Now we have the 8mm, I believe. 5.5mm, of course. How could I have forgotten? So you take these, and there's one in that corner, one there, and one there. All right, all 4 of those screws are in. I've cleaned the inside of the taillight. If you're going to be super anal about, having things clean, now is the time to do it. I wiped it down with some 70% isopropyl alcohol just so that it dries pretty quickly and gets all the grease off. There's a little dust on the other side, but that's fine. I tried to clean out the inside as best I can too. I'm a pretty impatient person, so it's not perfect, but it's good enough. And then I got this clear Loctite silicone. If this doesn't work well, I will let you know in the comments below or in the description or something, but I'm pretty sure this should work fine. And all I'm gonna do is put some of that weatherproof sealant all the way around here. You can see I used a different sealant that actually dissolved the plastic and sort of ate up some of the plastic around the taillight. That's kind of annoying, but I'm learning for you. All right, so let's put the sealant on. Remember to like and subscribe if this video is helping you. Also check out the comments below if you have any questions or if you have any tips. All right, so I put the taillight back in. You can see it here. And you can see the weatherproof sealant is just ever so slightly seeping out, which I think is a good thing. You could probably clamp it and let it dry, but I think this will be fine. This piece sort of holds it in. So, just remember when you're reinstalling this, be very careful. You can very gently just lift this up and slide the whole headlight in, and it should push in. It kind of takes some wiggling, but you should be able to get it. And the only other thing is the 2 bolts right there, or nuts rather, 2 nuts right there. And remember to plug in the taillight, and let's make sure it works. Ready? Ooh, beautiful. On the camera, there's a little bit of like tracing, it looks like, just because of like rolling shutter here. We do it like this. You see it's different? I think it's just rolling shutter. Yeah. But in person, all of them light up perfectly, so that's amazing. Yep. All right, everything's fixed. Thanks for watching. Remember, like, comment, subscribe. Really helps the channel. Hopefully I helped you out. It'd be great if you could return the favor. See you in the next one. Bye.